Hello, this is question 5 in the 2010 MAT. This question concerns calendar dates in the form, day, month, year, 2 days, 2 months, and then 4 year digits. The question specifically concerns those dates which contain no repetitions of a digit. For example, 2305 1967, because, we've got 8 different digits. We just got a 4 and an 8 missing. We can't have 07 12 1974. Well, no, because we've got 2 1s, 2 7s. That's fine. Use the Gregorian calendar throughout. This is a calendar system standard throughout most of the world. See below. Yeah. Oh, wow. They've given us a description of the Gregorian calendar down the bottom, but hopefully we won't have to worry about that unless you get one of those weird leap year things at the end of centuries and stuff. But let's see how we get on. Right. So for part 1, show there is no date with no repeating of digits in the years 2000 to 2099. Okay, so let's get a bit of a lay of the land before we step into this. So what have we got for dates then? For days, I mean, for our days then, when we're looking at days, these have to run, we're going from 01 up to 31. So they're going to have a 0 in, a 1 in, a 2 in. Then we've got 30's got a 0 in it, 31's got a 1 in it. Right, so that must include at least one of 0, 1 or 2. Right, so that's something to hang things on. Months we should get even more info on because there's fewer of them. So that's going from 0, 1 to 12. So the first 9 have all got a 0 in, and then so is 10 obviously, and then we've got 11 and 12 which have both got 1s in. So that must include at least a 0 or 1, at least one of 0, 1. Okay, this is good. Now we go to our part 1 then, because years, I mean, there's just too many permutations on this. So part 1, 2000 to 2099. So that's taken a 2 and a 0. Must include 2 and 0, 0 and 2. So therefore, the day must include a 1. Therefore, no available months. Yeah. Oh, well, that's pretty good. I suppose we could have said the month must include the 1 and then there's no available days, but whatever way round you want to put it. So that's okay. What was the last date before today with no repetition of digits? Well, it gives a fairly long life to this question, seeing as today could be any time in the 21st century, probably beyond. Right, so the last date before today. So we can't have, so first of all, we know it must be before the year 2000. And then we can't have 1990, well, we can't have anything in the 1990s. So we can't have 199X is not allowed. Then we're going back into the 80s. So we can't have 1989. We can't have 1988. So 1987 seems our first possibility, which means if we got 1987, we can't have November or December. We can't have October. Oh, wow. And then we can't have September, August or July. So we'll be going back to June. June is a possibility. So that would be 06 1987. So we can't have the 30th, the 29th, 28th, 27th, 26th, 25th. The 25th fits, 25th of June 1987. There we go. Explain your answer. So yeah, you might want to set this out a little bit more formally, but not much more than this, because you are just tracking back through the years until you find the first valid year, and then track back through the months till you find the first valid month, and then track back through the days until you find the first valid day. So providing you're showing that you've got that system going on, you don't need to have an essay explaining the answer. When will the next such date be? Right, so next such date. So we know it's got a, so we've got to have one of the, so at 0, 1 and 2, we know one of them's going into the days, one of them's going into the months, and then we could have one of them going into the year, right? So we'd have to have, if the year is 2xxx, then the 0 and the 1 must be in the day and the month. So we have to go up from 2. So earliest possible year must be 2, 3, 4, 5. 2, 3, 4, 5. Okay, so we want to have as early as possible in that year. So what's the earliest we could have in the year then? So we can't have, well, we can't have January, because that would take the 0, 1. So the earliest month, we can't have 0, 1 or 2 or 3 or 4 or 5. So it'd have to be 0, 6 would be the earliest possible month. So we've now got to the stage of 0, 6, 2, 3, 4, 5. We can have a 1 and a 7. So we've got all of our lowest digits. So that's the earliest day. Okay, this is going okay, I think. How many such dates were there? Well, this is the last part of the question. How many such dates were there in years from 1900 to 1999? Right, well, the 1 has gone in the year, that's for sure. So we must have the, right, so the 1 is in the year. So therefore 0 in the month, and then the 2 in the days, and 2 in days. Okay, so we've then got, but where can we put these in the days then? Then we've got yeah, well, let's put that. So we've got 1, 9, x, because we know it's in the 1900s. And then in the month, we have to have a 0. Well, we can't have 10 because the 1's already gone. So the 0 is going to have to be at the start. So we've got 0x. And then for the day, so we can't have a 0. So that takes out everything 1 to 10. And we can't have anything going up to 19 because the 1's have gone. Can't be 21, but it's got to be in the 20s. About 30. So no, we can't have 30 or 31 because the 0 and the 1 have gone. So it's got to be in that format. Okay. So, and then x can be, well, any of the other numbers, I suppose. So where x is any one of, well, what have we got left? 3, 4, 5, 6, 7, 8. Right, so we've got 4 options picking from 3. So the total, we haven't got anything that's going to go wrong here, have we? Because no, all the months will be valid because that's just going from March through to August. All of the days will be valid because that's just going from the 23rd through to the 28th. And all the years will be valid because we can have any numbers in there for years. Right, so the total permutations will be, so we got a pick from 6, then a pick from 5, then a pick from 4, then a pick from 3 for our 4 different numbers. So that's 30 times, so 90, then times 4, so 360. Right, that was nice. I like that question. Didn't feel as though it had an enormous amount of maths to it. It was more of a logic puzzle. But yeah, it was certainly something a bit different. But once you got the lay of the land, I think the key to it was having this bit at the beginning. Once you know that this 0, 1 and 2 have got to be split out, you've got one in the days, one in the months, one in the years, and particularly with the months having to have just the 0 or the 1, it really puts a whole load of restrictions on what is possible to do with perming these. I suppose, yeah, it's still, you want to write out slightly fuller answers than these. But even then, on part 4, if you said, well, 1 is in the year, therefore the 0 is in the month and 2 is in the days, well, that has set out this format. Okay, you might want to put a little bit more in there saying, well, if the 0 is in the month, then you could say, well, we can't have October, we can't have 10 because the 1 is in the year. So you might want to maybe write that one down just to put in there. So add a little line, October cross, because 1 is in the year. You know, little things like that. And then when you go into the days, well, it just presents itself really. If putting the 2, then the X. So yeah, I don't think you really need to say much more on the explanation than this. I think it's fairly self-explanatory. Like with the second and third parts of the question, because you're just counting backwards and then counting forwards. So we're doing the same thing again. You know, the same thing here. So the 0 and the 1 must be in the day and the month. So that's our earliest possible year. Then the earliest month, we're just counting up in exactly the same way as we counted backwards in part 2. So I think just showing that systematic method that you're using with some crosses and some ticks, and then just lay it out relatively neatly. And I think that's all the explanation that you'd need on that. So yeah, that's certainly a different question to anything we've come across so far.